Whenever you're ready.
Yep. Hi all. I'm Sowmya Madhavan. I've been in the industry for the last 10 years. I started off with HCL as a Windows analyst, and then was there for 3 years there. And then in VMware, worked as a technical support engineer for 3 years. And in the last 3.5 years at VMware, I've been working as a quality engineer developer, testing various software-defined data center products that VMware has been, releasing. So that's a quick intro about me, and I'm here to, give a brief talk on SDDC and cloud computing. So we all know that the future of the IT is software-defined. So Peter Drucker, he's a famous management consultant, and he had this famous saying: every organization must be prepared to abandon everything it does to survive the future. You cannot manage change, you can only be ahead of it. These are beautiful lines actually, which is so true. This is at the organization level, but if we consider at our individual levels as well, all that we've learned, all the technologies that we've learned from day one, be it C or C++, and or other technologies related to storage or networking, we have to be ready to, when we say abandon, it's like we have to be ready to, keep that aside and move ahead and be ready to learn and new technologies and stay ahead of them. So that's very important. I would like to say that, because I'm from VMware, and VMware is one of the leading virtualization company, which is, leading SDDC and cloud computing. Some references I would quote from VMware, but I would like to, just give this a disclaimer that some features will be subject to change, and then pricing, packaging, all these I'm not going to be discussing here. They have their own terms. Now, what's a software-defined data center? In a simple technical definition, it is the separation or abstraction of the control plane and the management plane. So what we do is a data center, if you consider a typical data center, it has these infrastructure components, which are your compute, your network, your storage. So what happens? What is a software-defined data center is you're adding the software flavor to each of these infrastructure components. You're trying to, virtualize them so that they can be provided as a service to the end user. So you're abstracting, and then you're making a pool of them, and then through automation, you're giving that as a service to your end user. That is SDDC in a very simple technical definition. Now, how do we get where we need to be? Now, all these components that I told you, be the network, the storage, or the compute, these have to be put together. And there are various ways of putting them together, but will all those ways be the best way or the efficient way? No. There are ways to do that in a very, beautiful way to get the best results of an SDDC. Now that I said that, SDDC means adding software flavor, abstracting these management and control planes, and giving them as a services to end user, does that eliminate the need of traditional data center hardware? No. There will still be a need for your physical servers, your CPU, your memory, or even the storage. But because of introducing SDDC, there's a lot of CapEx and OpEx reduction. If you had, or if you needed, maybe 100 physical servers to run your company, today you may need only 10. Because on each of those servers, you will be adding a virtualization layer, which will help you to create hundreds of virtual machines on a single physical machine. So there's still need for the physical servers. It's not that you don't need them completely, but we can efficiently and use all of them to reduce the cost and also give a seamless experience to the end user or to the customer. Now, so that's what a software defined data center. You have your compute, which you virtualize, you have the network, which you virtualize, and storage virtualize. Together, after virtualizing these core building blocks of your infrastructure through an automation, you provide that as a service. That's the cloud management and automation. That's where that comes in picture. Now, what is cloud or what is cloud computing? It's actually, it's a new operational model for IT, but it's just about, where your resources are clubbed together. They are, given as a pool of services, and these resources are delivered on demand. So you're not wasting your resources. Only when you need, that is delivered on demand. So cloud uses these technologies. So cloud is at the top level, and what is a serving technology under the cloud is your software defined data center. I'll talk about various ways of cloud. Now, I said the architecture of hybrid cloud. So when I said, you pool those, all these resources, software resources, be it your CPU, memory, your network, or your storage. So if you club these and provide within your organization, then that is your private cloud. Now, if you're doing this and giving that as a service outside of your company, then that's a public cloud where you're offering these services publicly. And what's a hybrid cloud? Is a mixture of both, where you have your services, you have all that data center software defined, and now you're using this to serve both your internal customers, who could be your own departments in your company, be it your IT department or your finance department, or publicly outside to another company. That's a public. So together you're giving this, that becomes the hybrid cloud. Now, what's the software defined data center vision? Like I've already said, right? So compute, we virtualize. So one of the leading virtualization compute software is the VMware vSphere, or which includes the ESXi and the vCenter server. So using these two, on one physical server, we install the ESXi, which is the hypervisor. That gives us the ability to run thousands of virtual machines. And each of these virtual machines can have their own operating system. Now, in traditional days, if I had one physical server, I could run just one operating system on that. Now, that's not the case. I have one physical server, I install a ESXi hypervisor or a workstation, which gives me an option to create multiple virtual machines on that. And in each of these virtual machines, I have a different operating system. So I have actually virtualized my compute. So instead of 10 physical servers that I was in need, I just need one physical server, and on that one physical server, I can have so many virtual machines running. So that's where my compute part of the data center is software defined. Now, if we think about the network, so now, though I said that compute part is virtualized, that doesn't mean that I don't need a physical server at all. I still need one physical server instead of 10. Similarly, when it comes to networking, so this, physical servers, which always have their own limitations. On one switch, it can connect to the number of ports that are there on that physical switch. Now, if I need to have, suppose a physical switch has, 30 physical ports on it. I connected 30 machines onto it. Now I have few more machines in my data center, few more employees who have asked for more virtual machines. Now I have to go buy another physical switch to connect those new physical machines. And then I connect these two physical switches for communication between these 10 machines that I already had, and then the 5 more that I'm bringing in. So my cost is increasing. But then all are on the same network. Now, if we introduce a software-defined layer of flavor to the networking, then This software will, for all the routing that has to happen within and across your subnets also, routing, this takes care of that. So if I have my virtual machines running on one physical host, I have virtual machines running on another physical host, ESXi host. To connect between these two, definitely we need a switch. But for the communication between those hundreds of virtual machines on these ESXi hosts, that can happen with the NSX or with the network virtualized component, which from VMware is called as the NSX. There are several such, network virtualization components, but the leading network virtualization component to name one is NSX. Now, this NSX, which has software routers, software switches, which will provide this network communication between virtual machines. So you reduce your capex again. You don't need as many physical switches as you need because the software layer provides that for the communication. This also extends to the VLAN. So VLAN is limited again by the number of VLANs that I can create, 4095. If the range is from 0 to 4095. But if I'm a enterprise customer, I need more than the 4000 VLANs, then which is the one that's giving me that capability is the VXLAN from NSX again. That's about the network virtualization component. Now, if we talk about the storage virtualization, so from VMware, so our main storage virtualization component is the VMware vSAN, which is a VMware Virtual SAN. So every physical host comes by default with some of the disk capabilities. But to install our operating system, we may not use all that storage that comes by default. We just use it for an OS, and the rest of the capacity is lying idle. But we access storage, from out, which could be your fiber channel storage or your iSCSI or your NFS. Now, how, without investing more with the default storage that, when I say default storage, it's the local disk of each physical host. The vSAN actually pulls all of these together, the physical disk of each individual boxes of physical hosts, and then it provides that as a shared storage to those ESXi hosts in a cluster. So there again, you don't have to invest on storage outside, and you don't have the, it's not easy to manage and control your data center, right? If you have FC storage shared, then there's so much of power that's needed, cooling that you need to take care of, and then IT, you need a separate storage admin to look into those and provide those storage to those customers. So by a storage virtualization layer, that is taken care. So you have your compute virtualized, your network virtualized, storage virtualized. Now these together, using a management software, or a cloud management software, depending on the user demand, these can be provided on demand. And one such product is the VMware vRealize Suite. vRealize Suite actually is a suite of components. So for these, provisioning and providing these compute, network, and storage, vRealize automation takes care of that. Now, if you want to orchestrate and add your own flavor, customize, then you have vRealize Orchestrator, which gives you that option to automate and orchestrate and customize based on your requirements. And then that's VRA, vRealize Automation, vRealize Orchestrator, and then there's VROps, vRealize Operations Management Suite. So all these we have network, we have storage, we have all these. There are so many machines running, but we need to have common plane to actually have a look at what's happening. So on operations management, what's my current capacity? What will be my future capacity based on the growth or the demands that I have? What went wrong? Did I get an alert? So all that is provided by the vRealize Operations Management. So these are examples or key terms that I'm telling that are from VMware, but there are several such products, but it comes back to the same software defined data center, and these such products are required for making your data center software based, and to provide the seamless infrastructure services and everything. Today we have infrastructure as a service, you have software as a service, you have platform as a service. So to provide all these services, you have a management or an automation tool that provides that as services to the cloud. Now, what are the IT outcomes of a software-defined data center? So I've actually started with the first one, right? Data center virtualization and standardization. So I just covered this some time back. So high equipment costs, because we need so many physical servers. You have manual operations of adding. If you want to add more CPU, if you want to add more RAM, then there's downtime because you already have an OS running, and then you have maintenance window. You need to bring it down and then add these. That's not the case when you have your compute virtualized. You have your physical box which is up and running. It has an hypervisor, but for these individual virtual machines, it's the hot add features where the machine is up and running. Because it's a virtual machine is actually a set of files. Now, because it is a set of files, it's easy to give it more memory or add more CPU to it while it's up and running. So it gives you that benefits of capex reduction. So what you see here is, you have your compute, storage, and network on top of the physical servers, which are all virtualized. And by this way, you extend all those services to the cloud. Now, streamlined and automated data center operations. This is what I said some time back. I have my data center up and running. It's been running for so long. I have been getting new requests from my, if I'm an IT admin, I have requests coming in from my own company to add more servers to some. There's another, one IT department or one R&D wants more SQL servers to be provisioned to them. And then there's another team who asks for something else. So we keep doing it, or the IT admin does it, but there need to be a way. Is the current capacity enough, or are they over provisioned? Or are they undersized VMs in it? Can I make it more efficient? So that's where on top of an SDDC, you need such operations management software that will help you give this visibility and ensure that your existing resources are efficiently utilized, and also you're ready to take up the demands that are coming in so that you're not too late in the game. Now, this is how it helps you, because it gives us all that information through one single pane of glass, where I know what is green, what is red, what is alarming, something went wrong. Can I, will it take care of it automatically? Yes, we can. We say that if something goes wrong, if this is what goes wrong, go ahead and fix it this way. You can automate and you can provide that remediation step. So without an IT admin's intervention, that will be taken care. But you still have a message that this is what happened and this is what was done to take care. So all this happens automatically. Next is the security controls native to infrastructure. Now, earlier, you have your virtual machines running on top of your ESXi, but for networking to take care, it has to access the physical infrastructure directly. Because of this, the provisioning is slow, the placement is limited, the mobility is limited, and it's hardware dependent. Because of the introduction of this network virtualization abstraction layer, everything is programmatic. You can place your workload anywhere and still have the network access You don't have to be, limited to be running on a physical host which has access to that physical switch itself. It can run on any ESXi host and still get connected to the outside world. And it's decoupled from hardware. It's firewall. In traditional data centers, these physical firewalls to manage security zones actually lead to high capex. And then you keep adding your zones, and then it also increases your admin opex to maintain so many security and so many firewall. But there are as software defined data center softwares which through the network virtualization software also take care of the security. Now, VMware NSX microsegmentation feature is one such thing, which will help you control security at the virtual machine level, not at your firewall level or outside at the physical network level. So it reduces the firewall capex, and it also increases security separation, and it reduces your admin opex, which is very important. Next is the hardware removal of hardware dependency and high availability and resilient infrastructure. Just to show here, the biggest virtual machines that would run is, if you have your Exchange server, if you have your SQL server that's running. Now, if you don't want it to be running on a single physical server, because if that goes down, then your entire company's Exchange is down, right? So if it is on the physical setup, you have one physical server running and then you have another box running for it, that's a duplicate server. That increases your capex. And what about storage in that application on two physical separate servers and to replicate data between them? That is again high capex. Now, how we can introduce high availability and also load balancing is that since these are all virtual machines that are running on physical hosts, they don't have the dependency that if the box goes down, they're all down. VMware's high availability feature, vSphere, the minute the machine goes down, in less than half a minute, the machine would come up and running on another ESXi host. So you have very minimal downtime. Or if you do not want to have that minimal downtime as well, then you can make use of fault tolerance, which means that there's another server running exactly as the server on another machine. So even if this goes down, there is zero downtime, and you have your servers and services up and running. What if the entire site goes down? Then you have the replication configured across your sites so that your region A goes down, you have the entire infrastructure up and running on another site. And then there's the app and infrastructure delivery automation. So when I spoke about cloud management softwares and the vRealize suite, this is what I referred to. So depending on the demand, services, it could be infrastructure as a service, it could be platform as a service, or any services based on demand. The cloud management software takes care of providing these to the end users. If it is within your organization, it's your private cloud. And if it's outside, you're serving it as a public cloud, and there could be a hybrid cloud as well. And it could be a service provider who's giving these services to the end users. So examples are, AWS and Amazon. These are all examples of such cloud management softwares. So we discussed about software-defined data center and how by virtualizing all these, we can provide those services to the cloud for end users to consume them based on demand. Now, how could I implement this? One is, you do it yourself. You design a custom architecture with all the knowledge that you have by researching, and you manually deploy and maintain these various software components that form a software-defined data center. Or there's another way where you still build your own, but you can be sure that while you're doing this in your own way, the design is validated by experts. So this VMware validated designs, which provide standardized architecture designs, and they give you blueprints which you just have to make use and deploy the way that has been said. And there are also deployment design decisions. Why is it being designed this way and not another way? Why is this design better than another design that you could opt for? So all that is very clearly explained. And as an administrator, you can actually look and understand and then deploy and bring up your software defined data center by following the validated designs. Another option is the easiest of all. It's a one-click software. You have the software, you install it, and in a single click, you have your SDDC up and running. Meaning, you have your compute that is virtualized and it's up and running, your network and your storage all deployed for you, along with these other products that I mentioned, like for your cloud management software, your vRealize suite, for your operations management, the vRealize Operations Manager, for orchestration, the vRealize Orchestrator. All these, along with that, you will have the SDDC up and running. Not only these, suppose for all the products that you have, you need to have a common log repository, because drilling down to individual products as to what went wrong, when did it go, if they have their own after 6 log files the log gets archived, we lose what happened, why did the server go down. Now we have something called log inside. We realize log inside, VMware's log inside product, which has a capability where you can redirect all the solutions, all the software component logs to this vRealize log inside, and there it acts as a single log repository for an administrator to view it. Now, so vCloud Foundation is that single click software that gives you the SDDC in one single click. Now, why validated designs? Like I said, these are prescriptive blueprints. They're standardized design built by the expert architects, validated by R&D engineers who would have validated it n number of times to prove that they are proven and they're robust, and they will cover a broad use cases. It's not only, if it is startup based company, there's a specific design that they can follow. If it's a medium sized company, there's a specific design. And if you're an enterprise customer, then you have an enterprise designed way of SDDC for you to choose from. And these are completely free. You don't have to pay anything. The validated designs are available on the public sites. You can just search on Google as VMware Validated Designs, and there you can see that there are designs that are available to bring up your software defined data center. And they're very comprehensive and very detailed. Like I said, right? Why is it designed this way? Everything is given a clear and neat explanation. Now, if there's if I'm deploying something in a distributed way, like not a single node, because a single node is a single point of failure. If I'm deploying that solution in a distributed way, then there's a justification why it's being done that way. So it's very comprehensive. Now, what's the simplest path to the hybrid cloud? Like I said, so server virtualization. And then you modernize your data center with private clouds first. You bring up an SDDC. In your company, you start delivering these services to your own departments within your company. And then you outsource that and provide as a service in the public cloud. And then in a hybrid cloud, in a true hybrid cloud, you manage both your private and the public cloud. And VMware's vCloud VCF, vCloud Foundation, is the one that gives both private and public cloud in a single click. Now, this is how it looks. Like I said, you have the private cloud, the public cloud. You have a lifecycle automation software that takes care of bringing right from the scratch. You just have a uh, a compatible physical servers, that is all you need, a rack with the hosts that are, with servers that are compatible with VMware's, you look into the VMware's compatibility guide and you'll be able to find that. And then if it's compatible, you once you have the vCloud Foundation software, it takes care of bringing up the entire SDDC on that a number of hosts that you have chosen. Compute, storage, network, all virtualized through the vCloud Foundation to give you an SDDC. Now, these are the consumption options, like I said, private cloud and public cloud. These are all the customers and hardware vendors who are certified: Dell, EMC, HP, Cisco, Fujitsu, Hitachi, Lenovo, Cisco. A lot of the top companies in the IT industry. Traditionally, building a software-defined data center is not easy. It will take 86 plus days or even 100 days. Following following the design that has been tested and validated, it will take you from 100 days to a week. And if you use the vCloud Foundation software, you can bring up your SDDC in 2.5 hours. That's great, right? Just imagine the time saving that you save, the time that you save, and the capex that you save. Yeah. So I just briefed on software defined data center and the various ways of bringing up a software defined data center and how it can be consumed in the cloud. So if there are any questions, I'm open to take.
Thank you so much, Sowmya. That was a great presentation. We have somebody on the line with us. If you have any questions, you can use the chat feature on Zoom, which is at the bottom of the screen, or you can turn your audio on by clicking the little microphone on the left-hand side, and you can speak if you have any questions.
Hi, Soumya. This is Runa. I had one question.
Hi, Runa. Yeah.
Yeah. When you talked about resiliency and fault tolerance, so is there something to be done on the code side also, or does cloud take care of it? Say I have a scheduler service and I was updating a database and it went down. Okay. And when it restarted, I wanted to start from the same point where it had got down. So something needs to be done in the code, or cloud will take care of it?
So nothing needs to be done at the cloud, Runa, but for the machine where the service was there and the database that it accessed, right? You need to ensure that the IT admin has configured it for high availability, or he has configured it for fault tolerance. Okay, if he has configured it for high availability, okay, which is high availability and fault tolerance are options available at the cloud. Okay, so if that is chosen, then if fault tolerance is enabled, you will get it. You will not even see any downtime. You will not even know that something happened. That is fault tolerance. Now, when I say high availability, it is like instead of it being down for an hour till someone fixes it, because he has enabled high availability at the cloud, maybe you will get it in less than a minute or maybe a minute. But there you will you will not be able to continue from where you were because a restart happened on it. Okay. But that option is available. Depends on what feature the VM that you're running, right, is enabled for. So the admin has to give you that service. But yes, without even knowing that something went wrong, there'll be continued services if fault tolerance is configured.
Okay. Thanks, Soumya.
Yep. Thank you.
All right, thank you so much, Sowmya, for your presentation. It was amazing, and we will be hearing from you again in 2 days on your next presentation.
Yeah, sure. Diana, I think I haven't received the Zoom link for it.
Oh, okay, I'll make sure to send it to you as soon as this is over. Okay.
Sure. Yeah.
All right, thanks everybody. We have another session in less than an hour, so we look forward to seeing you then. That topic will be on harnessing the power of creativity to thrive in a male-dominated environment. So I hope you will check that out. All right, thanks, Sowmya.
Thank you, Dana.
See you next time. Bye.
Bye-bye.